For your whole life, you've known what the night sky is supposed to do. The moon does its thing, constellations drift by. It's predictable, but on February 28, 2026, the rulebook gets thrown out the window. 6 planets, Mercury, Venus, Saturn, Neptune, Uranus, and Jupiter, are about to form a massive parade across the sky. This is not a drill, this isn't a movie, this is real, and it's happening for a reason that has nothing to do with luck, and everything to do with how our solar system is built. What you're about to see is called a planet parade. And it happens when a bunch of planets get crowded into one small section of the sky from our point of view. On February 28, 2026, right after sunset, this insane celestial lineup will be waiting for you. But this isn't just some random cosmic mosh pit. It's a stunning display put on by the basic laws of physics that run the universe. You might just see a cool, rare event, but what if I told you that understanding why this is happening is the key to understanding, well, everything. From how we get our seasons to how we launch rockets to other worlds. The alignment of these 6 planets isn't a coincidence. It's a clue written across the sky, and tonight we're decoding it. So, what are you actually going to see? Picture this. It's late February, you step outside about an hour after sunset, and you find a spot with a clear view of the western sky. That's where the action starts. The first thing you'll see, because you literally can't miss it, is Venus. It's the brightest thing up there besides the sun and moon, blazing like a searchlight low on the horizon. That's your anchor. Now for challenge mode. Very close to Venus, you can try to spot Mercury. It's always tricky because it's so close to the sun, and on the 28th, it will be fighting the twilight glow and setting fast, so you have a very short window. Using Venus as a guide is your only shot. Also, low in the west near this group is Saturn. It might be tough to see in the glow, so you'll have to look sharp. And Neptune, it's in the same area, but it's so far away and faint that you will absolutely need a telescope. Okay, now look a bit higher, up into the southwestern sky. Tucked under the famous Pleiades star cluster, you'll find Uranus. It's right on the edge of what the human eye can see, so your best bet is a good pair of binoculars to pull its faint greenish glow out of the darkness. Finally, swing your head way over to the high southeast and you'll see the king, Jupiter. It'll be ridiculously bright, outshining every star around it. The nearly full moon will also be hanging out nearby, which is a killer bonus. So you've got this incredible arc of planets stretching from west to southwest to southeast. Mercury, Venus, Saturn, Neptune, Uranus, and Jupiter. Realistically, Venus and Jupiter will be the easy naked eye superstars. The others invite you to look closer with binoculars or a telescope. It's a moment that makes the massive scale of our solar system feel just a little more real. To get why these planets form a line, you have to stop thinking of the sky as a big dome. The solar system is actually incredibly flat, like pancake flat. Billions of years ago, before the planets, there was just this giant spinning cloud of gas and dust. As it spun, it flattened out, just like a ball of pizza dough when you spin it in the air. The sun lit up in the middle, and the planets were born out of that flat spinning disk. That disk is what astronomers call the ecliptic plane. Every planet, from Mercury to Neptune, orbits the sun on this same flat plane. Their orbits aren't tilted at crazy angles. Mercury's is the most tilted at 7 degrees, but most are way less. Here's the wild part. We're on that racetrack too. Earth is right there in the mix, orbiting on the same flat plane. So because we're inside the system, when we look out, we see all the other planets along the line of that disk. Think about it. If you're a driver in a race, you don't see the other cars above or below you. You see them stretched out ahead and behind you on the same flat track. The ecliptic is that cosmic highway. It's why the sun, moon, and planets all follow a similar path across our sky. This parade isn't some magical straight line in space. It's just our perspective, seeing several other racers on the track at the same time. But that only explains the where. It doesn't explain the why now. For that, you need to understand speed. If the ecliptic is the racetrack, then every planet is in its own lane, running at its own unique speed. And they are not all moving together. The closer a planet is to the sun, the insanely faster it moves. Mercury is the sprinter in the inside lane, finishing a lap in just 88 Earth days. Venus takes 225 days, we take 365. But then you get to the giants. Jupiter takes almost 12 years for one lap. And Saturn? A slow 29-year journey. Uranus and Neptune are on a slow-motion marathon, taking 84 and 165 years. It's like watching runners on a giant stadium track. You have sprinters on the inside and marathoners on the outside. For most of the race, they're scattered all over the place, but every once in a while, from your seat in the stands, you'll see a few of them bunch up in one section of the track. They didn't plan it. It's just what happens when they all move at different speeds on the same course. This planetary alignment is exactly that. It's a temporary meetup that happens when the fast inner planets, like Venus, lap the slow outer planets, like Jupiter, and they all just happen to appear in the same part of the sky for us. This is not a true straight-line alignment in 3D space. That's crazy rare. If you flew a spaceship above the solar system and looked down, you'd see they're all still millions of miles apart in their own orbits. It's a line-of-sight illusion. The fact that we can predict this stuff centuries in advance isn't magic. It's math. It's the beautiful clockwork of our solar system doing its thing. And hey, if you're going to watch this, let me know in the comments which planet you're most hyped to see. And while you're there, smash that subscribe button so you never miss another one of these cosmic breakdowns. Okay, so it looks cool, but does this alignment actually do anything? You hear all these myths about alignments causing earthquakes or disasters. Let's be clear, they don't. The gravitational pull from these planets on us is basically nothing. The only two bodies with a real gravitational effect on Earth are the Sun, because it's a monster, and the Moon, because it's so close. The combined pull from all the other planets, even when they're aligned, is so tiny it's not even a rounding error. So if it doesn't affect us, why do we care? Because these alignments are a massive opportunity. For astronomers, getting a bunch of planets in one frame is super efficient. It's a chance to study and compare different worlds in one night. But the biggest reason these alignments matter is for space exploration. This is where we get to use the physics of the solar system like a cheat code. The most legendary example is the Voyager 2 mission. Back in the late 70s, the four giant planets, Jupiter, Saturn, Uranus and Neptune, were in a special alignment that only happens once every 175 years. NASA knew this was their shot. They launched Voyager 2 and used the gravity of each planet to slingshot it to the next. It used Jupiter's gravity to get a speed boost and aim for Saturn. Then it used Saturn's gravity to fling it toward Uranus, and Uranus whipped it onward to Neptune. This grand tour was one of the greatest things humanity has ever done. Without this gravity assist trick, a trip to Neptune would have taken 30 years. Voyager 2 did it in 12. This technique is the whole reason we've been able to explore the outer solar system, saving tons of fuel and time. The New Horizons probe that went to Pluto did the same thing, using Jupiter to shave years off its trip. So while this visual lineup won't shake the ground, the principles behind it are what let us travel to other worlds. So on February 28, 2026, when you look up at that amazing arc of 6 planets, remember what you're really seeing. It's not a weird omen, it's visual proof of our solar system's design. You're seeing the flat disk we were born from. You're seeing the perfect clockwork math of orbits playing out across billions of miles. It's a reminder that the universe isn't just random, it runs on elegant, understandable rules. Go outside and see the proof for yourself.